You probably recognize that x bar 1 minus x bar 2 minus mu 1 minus mu 2, except for I wrote 0 there, right? Which you would always write. And then on the bottom, it just says this, which is this is standard deviation, remember, x minus mu over sigma. But the standard deviation is defined in this document as this standard error times this, and the standard error is defined as this. So that's where the huge formula comes from. It's like they've got like things in 3 different formulas that you have to pull together. Anyway, let's just do it. So, were you going to ask a question?
Yeah, so when it's talking about the variances, is that the population variances or the sample variance?
It's supposed to be the sample variances. Or no, the estimate for the population variances. You don't know the population standard deviation, but you can tell if they're basically what it means when it says the variances are equal is it means that the populations are basically the standard deviations are about equal for the two things. Like for instance, if we're talking about like height of men and women, there's about an equal number of super tall women and super tall men. Granted, they're different means, right? Like the center of the data is in different places, but humans generally spread out the same way when it comes to height. So there the variances would be equal. But you might have to, like, you might compare the ACT and the SAT, and it might be like, okay, well, more people score really tightly in the ACT, like very rare you get a 36 or a 34 or something. Very rare you get like a 10, right? But the ACTs are more spread out, so those ones wouldn't be comparable with their variances. That's why the problem tells you. So it's kind of like we have an idea if the variances are equal or not, and we'll let you know. Okay. So the results of a state mathematics test taught by 2 different teachers at the same school are shown on the left, which they're totally not. So probably should have put that in there, my bad. Let's see where they are. Portions. Okay, so teacher 1 and teacher 2 Teacher 1 had an average score on their test of a 473. Teacher 2 had an average of 459. The sample standard deviation of this teacher was 39.7. The sample standard deviation of this teacher is 24.5. This one is how many kids were in the class is 8, and this one has 18 in their class. 473. No point. I think that's just leaking over from the other side. Can somebody like act like they're going to take the AP test right now and compare these two for me? Like say sentences that compares the two.
The second class had more of a group, I believe.
Yes, the second class had a bigger group, right? Than this class. What did you say? The second class, or is that what you said?
Mm-hmm.
How about their scores on the tests? Which class did better? The first class had higher scores. But what does the standard deviation mean?
That the second class was tighter than their mean.
Right, the second class was like closer to that 459. This class was probably spread out, which makes me think that maybe you had like a couple people who had amazing scores that brought that mean really high up. You know what I mean? Compared to everybody else. Because that's a big spread. So maybe you got a few people who scored really, really well that pulled everybody up. Okay. So let's do it. First thing we have to do is verify that we do not know the population standard deviations. And since there's nothing on here, then we assume that, that we don't know them. We know that these are independent classrooms because they're not the same kids, right? In the 2 classrooms, they're different kids completely, so they're definitely independent. Do you see how here it says population variances are not equal? So we're going to use the easier of the 2 formulas. Okay? H sub O, H sub A. So, can you conclude that there's a difference in the two teachers? So, what's our claim?
Not equal to.
That what?
They're not equal to.
That they're not equal to each other, okay. Now, what if instead your claim, like what if this was the AP test, and your claim instead was that they're equal to, and then you proved that they're not equal to each other? Do you see how that would also work? You just have to be very careful about, that's why you have to say that sentence. Because if you did a whole test where you said that H sub O was the claim, that would fine, you'd still come to the same conclusion as long as you say, I reject my claim that, or I accept my claim that, then they'll know what your claim was, and then they'll be able to understand the other way if you kind of flip the two. Do you see what I mean by that? So you're basically trying to conclude that there is a difference, right? But what if you did instead to show that there's a difference, you claimed there's not a difference. They're equal to each other. And then in the end you said, so it turns out that they aren't equal to each other. You know, see, it turns out I was wrong, which means that they aren't equal to each other. So you're still proving the point, you see what I mean? You just kind of went for the other side, but you're still proving the point, so that's why it's important to bring it back into context. Okay, let's see, alpha is 0.1, degree of freedom. All right, the variances aren't equal. So we need the smaller of n sub 1 minus 1 or n sub 2 minus 1. Which one is that? N sub 1 minus 1, so it's going to be 7. 8 minus 1 is 7. All right, now we're going to draw a bell curve. Left-tailed, right-tailed, two-tailed. Two-tailed. Remember, this is a t-test now, so we've got to turn to page A18, or you can grab that page you have in your notebook, which is the t table. If you need to use your book, you can. It's on page A18. If you look up the degree of freedom should be 7. We are in the middle of our 8.2 notes, Caitlin. I'm recording, so you can go back and watch the beginning again. Okay. Your timing gave David just enough time to find his T-chart, page A18. So degree of freedom is 7, and then we're looking at a two-tailed test of alpha is 0.1. I got 1.895. You guys get the same thing? 1.895 and negative 1.895. Okay, now we need to do the t-score. We're going to do this one by hand. T equals, I'm just going to write it out, x bar 1 minus x bar 2 minus 0. Again, you don't actually have to have that. I'm just putting it there so you know what I'm doing. And on the bottom is the sample standard deviation squared, 1 divided by n1. Is it plus? Yeah.